Alright, so I think this is recording now. Let's take a look at number 5. This is different than the others. We're just using tables to evaluate functions. We don't have equations, we don't have a graph, we just have this finite list in these tables. I suppose we could plot the points and read it from a graph, but here they define a new function to be the composition of f composed with g, and they're asking us to evaluate this new function when x is equal to 2. So that means over here we're going to evaluate this composition when x equals 2. And we think of that composition as that we start with g, and we're going to plug 2 into the function g, get an output, plug that number into the function f. So I don't have an equation to plug it into, but I do have a table. So I need to replace this g evaluated at 2 with a number. So I go into my table, and when x is 2, see I have a 2 over here, I need g at 2, which is 3. So I know that what I've highlighted in yellow there, that I can replace that's equivalent to the number 3. So now I need to replace this with a number. So I go back to the table. I enter the table looking for x equals 3. Here I found it, and then I read the output for f, which is 5. And that is our final answer. Let's take a look at the next one. Now they just happen to call the function in part B, they also called it h. It's not the same h from problem A. But it is a composition, it's just the composition is defined in the other order. We want to evaluate h when x is 0. That means that we're going to evaluate this composition when x is 0. If we plug 0 into f, what is the output? Alright, so the output is this f at 0. We come in when x is 0, we read that f at 0 is 3. So f at 0 I replace with 3. Now we need to replace this g evaluated at 3 with a number. We go into the table and we look for x is 3. So here it is. And we read off the output for g, which is 2. And that's our final answer for B. Here is another function they've called h. It's a new function that's different than a or b. We want to evaluate this h at 1. This h is defined to be a composition of two functions. However, before we plug this number 1 into f, we need to add 2 to it. So we have 1 plus 2. So we're actually, if we add 2 to that 1, we get 3. And that's 3 is our input into f. So we need to go to the table and replace f evaluated at 3 with a number. So we come in when x is 3, we read off f, that's 5. This 5 is now our input into the function g. So we come in when x is 5, and we read the output for g, that's 8. And we have our final answer that h evaluated at 1 is equal to 8. Here we have another function. They just happen to all keep calling it h. It's f composed with itself, and if we evaluate h at 2, that is the composition of f evaluated f of 2. We need to replace this f evaluated at 2 with a number. And we get that from the table. So when x is 2, f is 3, and now that's the new input. The output of f evaluated at 2, which is 3, now becomes the input for f evaluated at 3. See, we're not even using g. Not for this one. When x is 3, f is 5. Alright. For e, this e is different than the others. It is equal to a function composition, but before you plug in the number, subtract 1. So if we're going to plug in 3, before we actually plug in 3 into g, we subtract 1 from it before we evaluate it. So g evaluated at 2 is what we're looking for to get from the table. We need to replace that with a number. When x is 2, g is 3. When the input is 3, f is 5. Alright. I think this is the last one. H is this composition of fog minus the composition of golf for every point in the domain of H. We're trying to evaluate H at 0. Let's see if it's in the domain. Let's see if we get an output. So for the first number in this subtraction problem, we have to do this composition. And for the second number, we do composition in the reverse order. We need to replace g at 0 with a number. So when x is 0, g is 1. We also need to replace f at 0 with a number. So when x is 0, f is 3. Alright. F evaluated at 1, when x is 1, f is also 1. When x is 3, g is 2, and 1 minus 2 is a negative 1. There's our answer. Hey, I hope this helps.